There's a couple of rules, yeah. And we may have gone over some of, we may have gone over a couple of them already. Um, I don't, I don't know, I don't remember, but, we may have covered, oh, you gotta be kidding me. So every once in a while, this stupid thing connects to where I can't, like I can't see the mouse. See, like I can't see where the mouse is, and then I can just start writing. And it's really annoying, and it makes it very difficult to do. So I might not even do this, I might just do it up on the board. Just do that. Okay, so in pre-calc you learn, or you should have learned, depending on what stuff you were taught at the end of the year or how much of those videos you actually watched. That's a whole nother story, but all of these like exponential, and we're going to start with logarithm rules. Um, so it's important for derivatives and integrals that you understand these rules, just kind of going into it, um, to help simplify some of the processes. So let's see what you remember. So let's just we'll just do them one at a time, okay? And if you don't remember them, that's fine. Just tell me you don't remember them and I'll show you what it is. But these all relate to exponential, or I'm sorry, these all relate to exponent rules that you'll learn in Algebra 1, so. So log of any base, so we just use a generic b for any base, of two things being multiplied together. Do you remember what do you do with those? Right. We add them separately. So it's log, the base doesn't change. So we have log base b of x plus log base b of y. Okay? Now, typically I don't cover that and the division one separately because they're the same thing. Combining the first one with the second one, you can get the subtraction rule, right? You know, like you may have learned it separately, like log base b of x over y as log base b of x minus log base b of y, right? But if we do, if we look at it like this, log base b of x y to the negative first, we can do this in combination with this and get the same thing. So you just put two rules together to get the other rule instead of memorizing a third rule, right? So what do we do with this? If we have an exponent here, what do we do? You remember what you do with the exponents? No? It gets moved out front, right? So the exponent gets moved out front. So this right here, right? This right here, if we take this exponent or this logarithm rule and we combine it with this one, that gives us log base b of x plus log base b of y to the negative 1, and then we just move it out front and we end up with the subtraction rule, right? So this is the same thing. This is basically just a rewrite, basically doing what I just did right there. Move the a up with a negative power, move the negative power out front, right? So they're all the same thing. Okay, are we good there? What is the log that has a base of e? That has a special name. That's the natural logarithm, right? You also had another one with a base of 10, which was called the common logarithm, which was just log without any base written. But log base e, or the natural logarithm, is much more important for AP Calc, and you'll see why in one of these rules. So what is, if let me think how to word it. If we had, there's a significance between logarithms and exponentials, right? Like there's a kind of like a general rule that when you're dealing with logarithms and exponentials, that allows you to work with them a lot easier, okay? And it's kind of the same thing as roots and exponents, right? Like if you have a cube root and an x cubed, those are inverses of each other, right? Because they had the same power, basically the same power, the same root. And it's the same thing with logarithms. It's all based on it's all relating to the base of the logarithm and the base of the exponential. So if you have an ln of something and e of the same something, those are inverses. Or if you take ln of e, you end up with 1. Okay, and just like you could take log base 5 of 5 raised to some power, and the log base 5 and the 5, they cancel. Right, do you remember that? Like if you have log of a base 5, and then you take 5 to some power, this is just equal to that power. Because the logarithm with a base matching the base of the exponential function, they cancel each other out, and you're just left with the exponent, right? So now that's important because in here, so let's go back to now when we did our first, well, very first time we started derivatives, way back in like September, we did the power rule, right? Where we just moved the exponent out front, we subtracted it by 1, and then we just went from there. And we were told that this is true for when n is not equal to 0 because we can't, that just kind of wipes out the whole thing. So this is where logarithms come in, okay? If you remember, we never did an integral that left us with x to the negative first, right? Like if we started out with x to the 0, this is not right, but I'm just saying, like, follow me here. If we take this and move it out front, then we would have 0 times x, subtract 1 would be x to the negative first, right? Just thinking about our power rule. Now, this is why it doesn't work for 0, because it would just wipe out the whole thing. But this part of it, we still have to have something that gets us that, right? Because that's one derivative that we haven't gotten. It's also one integral that we've never done. Like we haven't done the integral of 1 over x yet, right? I don't know if you noticed that or not. Like we've done 1 over x squared, but we didn't do this because if we start with -1 and we add 1 and then divide by that number, we have a problem, right? Because now we're trying to divide by 0. This is where logarithms come in. This is what gets us to logarithms and back and forth, okay? So the first one here, logarithm, we're going to start out with the generic one, the general form. If we take the derivative of a logarithm, log base b, any base, not any base, but any bases that we're restricted to from pre-calc, like it has to be positive, and I believe, what else? There was something else. It has to be positive. I think greater than 0 may have been the only restriction that we had. But it's 1 over x and then ln of whatever the base is. Okay, so now if we do ln, okay, so let's think of this in terms of log with a base of e now of anything. What are we going to end up with? So we always start with 1 over whatever this is right here, which in this case is just an x. So this ln, the ln of the base is always there. Like that's part of that formula that's always there. But when our base is e, like this, and we do ln of e, what does this equal? What's ln of e? It's just 1, right? They just cancel each other out. You're left with 1. So the ln of x, the derivative of ln x, sorry, I should word that better. The derivative of ln x is just 1 over x. Okay, so there is that part of the denominator that's ln of the base, but because the base was e, it's just a 1 and we don't write it. Okay, but it's still there, it's just simplified. Okay, we good there? So now pay attention to what we're taking the derivative of. What is this? How do we write this? So the derivative with respect to x of ln of u is now what? Start off with the ln. What's the derivative of ln? Ln of something, it's always what? Ignoring what we're taking the derivative of. So ln of something, the derivative of that is what? It's just 1 over the something, right? So now, if the something is not in terms of what you're taking the derivative of, what else do we need to do? What's that? Yeah, same thing. Chain rule, implicit differentiation, same thing. So we have to do the derivative of the inside. So it's 1 over u times u prime, or du dx. Okay? Now, they prefer to write it like this. You'll see the formula, if you want to call it a formula. You'll see it written like that. Personally, the way that I like to write it is like this. I like to write u prime over u, because if you have like ln of x squared, then you're going to put 2x over x, just do the derivative on the numerator and then whatever's on the inside on the denominator. Okay? And you'll see what I'm talking about in the other examples. Not the other examples, in the examples when we get into them. All right, so then we throw in a different base here, and it doesn't change anything. It's 1 over u. We have that ln of the base. If the base is not e, we have to write it then, and then du dx, which again, like I said, I prefer to write this as u prime or du dx all in the numerator, and then u ln b. So I kind of do it, I think, usually when you're doing chain rule, you would do the derivative of the outside function first and then the inside. But for ln, I do the derivative of the inside and put that on the numerator and then put over whatever that function is before I took the derivative of it. Okay? So I'll show you what I mean here. We're going to do, I think, 6 examples. So some of them a little easier, and then we'll get into some a little more challenging ones. So. Okay, anybody need those? We're good? Ready to go? All right. So we like ln's, and you'll see when we get into logarithmic differentiation, you have the option of taking any base that you want to. You could do log base 10, you could do log base e and use ln, or you can do log of any base. But for the sake of derivatives and integrals being easier to do, we always kind of just stick with ln, right? Because we don't need that extra ln of the base in the denominator. I'm getting ahead of myself because that's what we're going to talk about tomorrow, but anyway. So when we have the derivative of ln, the denominator is always this, okay? So x cubed. The numerator is just the derivative of that. Okay, because that's our inside function now. Outside was ln, inside was x cubed. So what's the derivative of x cubed? 3x squared. And then we just simplify, and we get 3 over x. Good? Next. We got ln d dx, the derivative of ln x to the 4th minus 3x squared plus 4. Okay, are we ready? So what I do is, if I know that, sometimes there's a lot of extra stuff going on, you'll see some of these problems. But I like to just take the derivative first, put that as my numerator, and then over, that's my denominator. Now, it doesn't really matter which one we write first, because you can just write x to the 4th minus 3x squared plus 4. And then what's the derivative of that? What goes up top? 4x cubed minus 6x. Now, we always have to make sure that it is in its simplest form. Okay, so we need to see, can we simplify this? So if we look at the numerator, I mean, we could factor some stuff out of there, right? We could take a 2x out. But let's look at the denominator. Is that something that we can factor? So what are the factors of positive 4? What are the numbers that will multiply to give us positive 4? What's that? 1 and 4, or 2 and 2, right? So, and they're negative. So like -1 times -4 are either both negative or both positive, right? So there's no way we're going to get -3. If this was a -4, then we could. We could use -4 and +1, right? And that would factor to x squared plus 4. I'm sorry, x squared minus 4, x squared plus 1, right? But since this is a positive, we can't do that. So don't waste your time on the numerator, okay? Usually that's what I like to try and do is start with the denominator, because typically that'll be the more challenging one to do. But if it can't be simplified, then don't simplify any of it, okay? These will be a multiple choice question on your AP test, so you're just going to look, and if it looks like that, you know you're done. Or if it has, 2x out front and then 2x squared minus 3, you just look at the answers and see which one matches it. Follow what I'm saying there? Yeah, okay. All right, now, this one probably looks a lot more challenging than it is, okay? And I've already seen people take this and multiply the whole thing out and then take the derivative of it, which is perfectly fine. You can do that. That's way more work than what you need to do, okay? Because by using 2 of our logarithm rules, we can simplify this to a much nicer, easier derivative, okay? So let's first of all look at this. What's one rule that we can use? Exactly. So we notice we have the multiplication rule here, right? Multiplication. So we have ln of x minus 2 quantity squared. I'm only going to put one bracket there, sorry. X minus 2 quantity squared plus ln of the second part, which is x squared minus 3 cubed. Which, just by doing that alone, even if you don't recognize the other rule, doing that alone is much simpler than, because if you take the derivative of that the way it sits, you have 1 over all that stuff, and then the derivative of the numerator, you have to use chain rule and product rule. So you got derivative of the first times second, which is always going to involve a chain rule inside of that. It's possible, but there's a lot more room for mistakes, right? So doing something like this using your logarithm rules, it makes it so much easier. So what else can we do? Right, so now we can just take these and say, well, this 2 can go out front, this 3 can go, oops, I didn't go far enough, out front there. So we got 2 ln x minus 2 plus 3 ln x squared minus 3. And now the 2 and the 3 that are the coefficients, they're just left out front, okay? With me so far? Yeah? Okay. So we got 2. I'm just going to leave that up. Well, we'll do this. No, I don't like that. Leave it up top. 2 times something. So what's my derivative of this part? So I just dropped the 2 down. What's this derivative? What will the top be? Let's start with the bottom. What's the bottom? It's right. It's just x minus 2. That doesn't change at all. What goes in the parentheses on the top then? One, right? It's just the derivative of x minus 2 is just 1. Okay? Plus 3. Denominator is x squared minus 3, and the numerator is? We got the 3 out front. Derivative of the inside is 2x. So 2 over x minus 2 plus 6x over x squared minus 3. You might see it written like that. You might see it combined into one fraction. It all just depends. Okay, any questions on that one? No? You good? Okay. I think I got 2 more. 3 more. There we go. Okay. So now, using the chain rule, again, we start with the outside function and work our way in. So what's the outside function? And the derivative of sine is? Cosine, right? Yeah, we're coming off of integrals, which was a negative cosine, right? Oops, and I'm writing sine anyway. Yeah, so cosine, oh, that's terrible. ln x times the derivative of the inside is what? The derivative of ln is 1 over x, so we're left with cosine of ln x all over x. Okay? All good with that one? All right, now, I've been sticking with ln's. The last couple are other ones, other bases, okay? So the derivative of log base 2 of x cubed. You got 2 ways you can start this out, okay? What's one? What's that? Move the 3 out front, right? Which I think the first problem I did was like that, right? But I did it the other way. So I could have brought the 3 out front and I would have ended up with the same thing. 3 times the derivative of ln x is just 1 over x. So for this one, and you can see that one, it's simplified to give us the same thing anyway. And the same thing would happen here. But yeah, so we can take our 3 out front. And now we're just left with that. So this is supposed to look like a 2. I don't know why I try to fix stuff. It just looks worse. Log base 2. There we go. So we got a 3. And now what is log base 2 of x? First of all, logarithm, the derivative of any logarithm is always, what do we start with? It's always just 1 over this stuff, right? Like that's what we're always starting with, is like that 1, which we already have a 3 there, but. So 3 over x, but now because this logarithm does not have a base of e, the denominator also includes ln of the base, so ln of 2. Okay? Are we good there? What's that? Probably not, because you still have an x there, so they wouldn't have like a decimal with the x. You would see it written like that. But while we're on that topic, a lot of times I see, or you'll see a problem like this, and people put like 1 over x, or they put 2 over x or something like that. What is this? What is this? Not, I mean, I don't know how to ask that question. Um, I'm just going to say it. ln of 2 is a constant, right? If you can plug that into your cal, there's no variables in there. That's a constant. What's the derivative of a constant? 0. Okay, so I see stuff like this, or like 1 over 2, because you're in the mindset of like this as being your denominator, so you can do 1 over 2, or something like that. But if this is a constant, your derivative of the constant is always just 0. Okay? Another way to think of that is if you started it off this way, what else would you need to have up there? Because this is not in terms of x. So what else would you need to have on the numerator? The derivative of the inside, right? Right? So if we have like ln of x cubed, like in that first problem, we put 1 over x cubed, and then we did the derivative of the top, that 3x squared, right? So if you did your derivative of that inside, what's the derivative of 2? 0. So either way, we're getting right back to 0. Okay? So just be cautious of that, because I do see that a lot. So okay, last one. Log base 4 of 1 over x squared. How do you want to start it? Yep, that's one option. And then what do we do after that? Sorry, I cut you off. Exactly. So x to the negative 2. And then we're going to move that out front. So the derivative of negative 2 log base 4 of x. Okay? And even if you went about it the other way and you just did, 1 over x to the negative 2 times the derivative of that, it would all simplify to be the same thing, but sometimes usually doing this is easier. It's fewer steps. So what's my answer now? What goes up top? Any takers on that one? Negative 2. And on the denominator, it's going to start with what? X, and then ln 4. Okay, and that's your final answer. We'll leave it like that. Okay? All good? Yeah? All right. So there you go. There's some problems.